From designing life-saving drugs to delivering personalized patient care, artificial intelligence is poised to revolutionize healthcare. But there's a big risk lurking below the surface: how to train and run AI models using sensitive patient data in a HIPAA-compliant fashion. So let's define the core problem. Most of us understand encryption. We encrypt data at rest, and also when it's in transit moving across networks. But there's a third critical state: data in use. When your GPU and CPU are actually processing data, that data needs to be decrypted. This introduces significant security and HIPAA compliance risks. With respect to security, for example, we know there are many forms of container escapes and lower-level security issues in multi-tenant architectures that make unencrypted data in use a viable attack vector. These security and architecture issues also represent potential HIPAA compliance challenges. At Corvex, we built our AI cloud to solve this exact problem. First, we offer HIPAA and SOC 2 compliant virtual private clouds. Now, your sensitive data is protected through a combination of policies, controls, and architecture in order to minimize risk. But the real game changer is how we solve the data in use problem through confidential computing. So what is confidential computing and how does it work? Confidential computing is a means to create hardware-based trusted execution environments, or TEEs. A TEE is like a secure, isolated black box built directly into the processor. Your encrypted data and your encrypted AI model weights go into the black box. The GPU and CPU do their work inside this black box, and only the results come out. Now, the raw data is never exposed. Not to the attacker, not to the operating system or hypervisor, not even to Corvex as your AI cloud provider. So, how does all this directly help you comply with HIPAA? It provides technical safeguards for some of the most critical parts of the HIPAA security rule. First, it addresses access control. The security rule requires you to limit access to electronic protected health information. Trusted execution environments are the ultimate access control. They ensure only authorized AI processes can access decrypted data. Second, it ensures data integrity. The security rule also requires you to protect PHI from improper alteration. Data is now processed inside a sealed, tamper-proof environment with remote attestations. Now, integrity is guaranteed during computation, and auditable proof is logged. Finally, it supports the minimum necessary rule. Only the results of the computation are exposed, not the PHI. This aligns with the principle of using only the minimum data required to do the job. So what does this mean for you as an AI innovator in healthcare? It means you can safely train an AI model on real genomic data with complete confidentiality and compliance. It means two hospitals can collaborate and train a single diagnostic model without ever sharing their private data sets. It means a health system can build models on EMR data with documented, auditable proof. And finally, it means payers can safely design new fraud detection system on millions of claims records. Look, security is essential, but not every cloud can enable confidential computing. As you consider AI cloud providers, be sure to inquire about confidential computing in addition to HIPAA certification. And while you're at it, also probe on your AI cloud's performance. Are you merely achieving benchmarks on the latest generation of Blackwell and Hopper GPUs, or are you absolutely crushing those benchmarks by over 300% because your AI cloud also offers hardware and software-based optimizations like Corvex's Ignite product? Let us show you how confidential computing on GPUs accelerated by over 300% can better secure your protected health information and lower your total cost of ownership. If you're an innovator in healthcare, I'd love to speak with you and see how Corvex and our team can help you achieve your goals in healthcare AI.